Okay, so today we start with chapter 4, priority driving scheduling for periodic tasks. Okay. So in this chapter, we will learn about the fixed priority algorithm, which is rate monotonic and deadline monotonic. Okay. The dynamic priority algorithm, earliest deadline first and least slack time. Relative merits of fixed and dynamic priority scheduling, schedulable utilization, and proof of schedulability. We will check the proof of schedulability of each type of algorithm. So, schedulability test. Test to determine whether a feasible schedulable exists or not. So first, sufficient. If test is passed, then tasks are definitely schedulable. If test is not passed, we don't know. In necessary case, if test is passed, we don't know, but if test is not passed, tasks are definitely not schedulable. And in exact, we compile both sufficient and necessary at the same time. We will take example how to check the schedulability test. Okay, let's start with the first type of algorithm, which is rate monotonic scheduling. Okay, best known fixed priority algorithm assigns priorities to tasks based on their period. So the shorter the period, the higher the priority, as I explained to you in the lab session. The rate of job release is the inverse of the period. So jobs with shorter period have higher priority. Okay? Or in other words, we can say this type of algorithm is based on priorities. A higher priority process will preempt a lower priority process. Okay? This is important to know that the higher priority process will preempt a lower priority process. How to define which one has higher priority based on the period. Okay, so look to this example. We have here 3 examples. Task 1, period 4, execution time 1. Task 2, period 5, execution time 2. And task 3 with 20 period and 5 execution time. Okay, so which one is the higher priority here? The least period. So task 1 has higher priority, then the middle priority, which, task 2, okay, and the higher period has lower priority. Okay, and this how to find the rate. You just divide the this is the sorry, this is the rate 1 divided by 4 here. Okay, this is how to check the schedulability test. You divide the capacity by period. Okay, but to find the rate, you divide 1 by the period. Okay, let me show you. Maybe this is not clear how to find the how to draw the this type of algorithm. Wait, let me show you how to draw. Okay. So following that example, task 1, four and 1, task 2, 5 and 2, and task 3, 20. You can see my screen, yeah, correct?
Yes, sir.
Okay. Okay. How to draw the diagram or the timing diagram of rate monotonic? This is the rate monotonic. Okay. First of all, you have to find the higher priority. Okay. Which one higher priority? And the next middle priority and the lower priority. So here the higher priority is task 1, then task 2, then task 3. Okay. Now we start to draw our timing diagram. Here the hyper period you already know how to find it. It will be 20. So our timing diagram, we draw it from 0 until 20. Okay. Okay, first of all, please follow my steps one by one. Okay. First of all, the first step, you need to define each task interval, each task period. Okay. The first one, draw the higher priority. Okay. Task 1, it represent task 1 with the blue color. Task 1. Okay. And defined for each period. So each period from 0 to 4, the period is 4. So 0 to 4, this is the first period. This is the second, then third, and so on. Okay. So each period by 4. The next task, try to use another color. The next task based on the priority, task 2. The period is 5, so define the period for each. This would be the first period of task 2. This will be second period from 5 to 10, then 10 to 15, and 15 till 20. Okay, that's for task 2. For task 3, is 20. Okay, this is for task 3. Okay, I repeat, the main important rule here using rate monotonic, that a higher, it's based on priority, okay? A higher priority process, a higher priority process will preempt a lower priority process. That's mean task 1 will preempt task 2 and 3, okay? And task 2 will preempt task 3, since task 2 higher priority than task 3. Okay, that's the mechanism here. The higher priority will preempt the lower priority process. Okay, so let's start now. First of all, we here at 0. At 0, how many ready process to execute? How many processes ready to execute?
3, sir.
3 processes, correct. Task 1, task 2, and task 3. So this is the first step to check how many ready process to be executed. The second, we follow the given rule based on our type of algorithm, which is rate monotonic. It's based on priority. So we first execute the higher priority. Which task has higher priority?
Task 1.
Task 1. So we execute task 1. How many units we need to execute of task 1?
1, sir.
1. So we execute only 1 unit each period. That's mean in this period, we need to execute only 1 unit. In this period, 1 unit, and so on. Okay? For task 2, in this period, we need to execute 2 units. In this period, we need to execute 2 units, and so on. Okay? Okay, so we execute that 1 unit of task 1. Done. For the first period, we done with the first that unit. Okay, after we complete executing the task 1, what the next task ready to execute? Both. Task 2, task 2 and task 3, both of them are ready to be executed. But which one we need to execute first? The higher priority. Which is task 2. So we execute task 2 from 1 until, who can tell me?
3.
Until 3, because 2 units.
Yes.
Correct. Task 2. Okay. Now, what we can execute at unit 3? At unit 3, what we can execute here? Anyone? What we can execute from unit 3?
Task 3, sir.
Task 3, correct. We execute task 3. How many units we need to execute of task 3?
5.
5 units. Okay. So, red color. Okay. So we execute from 3 until? Harry?
Until 7, sir.
Until 7. Other students agree with him? Huh? Until 8.
Actually, until 4, sir.
Until 4.
24.
Until 4 or until 8?
7.
Huh?
7, sir.
Until 7. Who's okay? Who agree with
8.
7 until 8? Everyone agree until 8? Until 7 or 8?
No, sir. Disagree.
What What the correct answer?
4 supposed will be until 4, and then it will be delay for the next
Exactly. What? Exactly. Excellent. Why?
Because it's n until task 1.
Because what?
It's n at task 1. We
Because
exit the task.
because there is a new period of task 1.
Yes.
At 4, we'll start a new period of task 1. Since task 1 has higher priority than task 3, as I said just now, the higher priority will preempt the lower priority. Even we start to execute task 3, but once we reach to the beginning of task 1 period, the beginning of the higher priority period, the higher priority will preempt the lower priority. Okay, so we cannot execute the whole 5 unit of task 3. We execute only 1 unit. Once we reach to the new period of the higher priority task, we stop. Okay, task 3, we stop here because there is a new period of the higher priority, which is task 1. Okay, so we execute task 1. At this unit, at 4, we execute task 1. How many units need to
1
execute of task 1? 1. Means from 4 until
until 5.
5. Okay, done with task 1. Can we continue task 3?
Okay.
cannot, because the new film of the task 2 have been
Exactly.
started.
Exactly. So task 2 also has higher priority. And task 2 also will preempt task 3. So here we need to focus on the higher priority. Which has higher priority? Execute it first. Okay? It's too simple. So at 5, we reach to the new interval of the task 2, new period of task 2. So we execute task 2. How many units need to execute task 2?
2
2 units. That's mean from
until
5
7. 7.
until 7. Okay. What about 7? From 7, what we can execute now?
Can execute task 3.
Exactly the rest of task 3. We execute only 1 unit from task 3, so
Yes.
the rest is 4.
Yes.
So that's mean we execute from
1
7 until
8.
exactly until we cannot execute all the 4 units until 8. Why until 8?
Because task 1 is the priority.
Exactly. Because there's a new period of task 1. Task 1 will preempt the lower priority tasks. So we'll preempt task 3. So here new period of task 1, we execute task 1. How many unit? 1 unit.
1.
Okay. At unit 9, what we can execute?
Task 3.
Task 3. How many unit?
1.
1. Why only 1 unit?
Because there is task 2 beside.
Yeah. Start new period of task 2. Since task 2 has higher priority than task 3,
Yes.
means task 2 will preempt task 3.
So we'll execute task 2 now.
We'll execute task 2 from
Unit from 10 to 12.
correct. Task
So we'll start task 1 again.
task 1 again, correct.
So we can execute task 3.
Here we can execute task 3 because if you notice here, in this period, task 1 terminated its task. For task 2, in this period, task 2 terminated its task. So we can execute task 3 or the rest of task 3.
Yes.
How many units you execute of task 3? Already 3 unit.
Two more.
2 more. 2 more. Okay. So can we
15
execute the
until-
2 unit?
Yes, can until 15.
Yeah, no any process will preempt it.
Yes.
So this is task 3. What about from 15? Unit 15?
We'll start task 2.
Task 2. How many unit?
1.
Why 1? Here 2 unit. Task 2, 2 unit.
Because there's task 1 in 60.
Exactly. Because task 1 has higher priority than task 2.
Task 2.
So in the previous timing diagram, all this only task 1 preempt task 3. Okay? Never preempt task 2. And in this case, in this location, task 1 will preempt task 2. So we execute task 2 from 15 until 16, and we stop because at 16 new period of the higher
Task one.
priority task 1. Sorry, 2. Only 1 unit. Then we execute task 1. 1 unit. Then what we can execute?
Task 2.
Task 2.
Yeah, because left 1 more unit.
Yes, correct. Okay. Next, at 18, what we can execute?
No more task 3.
No
Yes,
more
sir.
tasks, correct, because all of task already terminated its task. So this will be our idle. Okay. That's the way how to draw or to schedule the rate monotonic scheduling. Any question? It's too simple. It's based on priority. The higher priority will preempt the lower priority process. Do you understand? Yes, student. Any
Yes,
question?
sir.
Yes,
Yes.
sir.
Okay. So let's back to our slide. Okay. So this diagram, it's similar to this one, but here it's more clear. Okay. Same in the slide, same the result. And you see here from 18 to 20, we have idle. There is nothing to be executed. Okay, we go to next schedulability test for rate monotonic. Okay. As I told you, this you need to follow this formula. Here you divide the capacity by the period, and this will be our utilization. Okay, will be our utilization. The utilization should be less than, equal or less than utilization bound. Okay, will be our, how to find the utilization by divide the capacity by the period, and should be less than the utilization bound. This is the utilization bound of one process, will be 100. If we have 2 processes, okay, will be 82.8%. Of 3 processes will be 0.78. 4 process will be 0.75. 5 process, and so on. Okay, this is the utilization bound. The formula here, how to find or how to test the schedulability test. It's the utilization the utilization should be less than the utilization bound. Okay, this is the formula for rate monotonic, and this is for EDF, earliest deadline first. That always the utilization bound will be equal 1, and so the utilization should be equal or less than 1. Let's take this example. Task set some period with capacity and okay, the task 1 has 2 execution time with 4 period, and task 2 1 with 8. Okay, how to find or how to test the schedulability test? Schedulability check, you see we divide the capacity by period, plus this is for the first task, plus for the second task 1 by 8, we get 0.5 plus 0.125. Okay, and we get 0.625. This will be our utilization. This is our utilization. The utilization should be equal or less than utilization bound. From where we got this one? From how many? From the process, the number of processes. How many processes do we have here? We have 2 processes. So we back to, for 2 processes, the utilization bound will be 0.2. Okay, 0.2. So is 0.625 less than 0.82? Yes, it's less. That's mean, yeah, it's schedulability. It guaranteed to be schedulable. Okay.
Sir,
Yes. Yes. Hello. Hello. Okay.
yes, sir.
Yeah. Do you want to ask anything?
Yes, sir. Can you hear me?
Yes, I can hear you.
Okay, so I don't understand the equation for 2 and then bracket square root 2 minus 1.
This is the formula. This is the formula. How to find the utilization bound. And this will be given in the question, by the way.
Okay.
This is the formula how to find these numbers.
Oh, okay.
How to find the utilization bound.
Mm-hmm.
Okay. So
Okay.
this is the first example. Let's check the second example. This is the second example. Let's see how to find. So here we have 3 tasks. Okay, here we have 3 tasks. 27, 50, 10, 35. Okay. So we divide the first task, which is the capacity, divided by the period 20. Okay, we need to find the utilization. We need to find the utilization capacity. 70 divided by 20, 10 divided by 50, and 5 divided by 30. 10 divided by 50 plus 5 divided by 30. Okay. So 7 divided by 20 will be 0.35. 1 by 5 plus 0.2. 5 by 30 0.16. Okay, equal 0.72. This is our utilization. Okay, this is our utilization. So this the first step to find the utilization. Then you can check for schedulability, rate monotonic schedulability or EDF schedulability. Let's check for both of them. Let's check for both of them. Rate monotonic. First for rate monotonic. Okay, the formula that utilization bound. The utilization should be equal or less than utilization bound. Okay, so we get utilization. We get 0.72, and the utilization bound, you can find it by the formula given here or this table. So how many processes do we have here? We have 3 processes. What is the utilization bound of 3 processes? 0.78. 0.78. Is it schedulable? Is it schedulable for rate monotonic? Yes, it's schedulable. What about EDF? What about EDF? As I said, the utilization bound of EDF equal, what is the utilization bound of EDF? 1. It's 1. So in this case, is the utilization equal or less than 1? What's the utilization? 0.72. 0.72. Is 0.72 equal or less than 1? Yes. So this question is schedulable for both type of algorithm. For both type of algorithm, which is rate monotonic and EDF, earliest deadline first. Okay. Okay. Harmonic periods test. Harmonic period test. What does it mean harmonic? What does it mean harmonic? It's a list of numbers or a list of periods wherein each number divides every number after it. Okay, I repeat. The harmonic is a list of numbers or period wherein each number divides every number after it. Let me give you example. For example, task 1, 4, and 1. Task 2, 6, and 2. Is it harmonic? Okay, let me give you few example and you tell me which one harmonic, which one not. 10, 2, Which one harmonic, which one not harmonic? I repeat, the harmonic means a list of periods or a list of number where each number divides every number divide every number after it. We have 3 examples here. 1, 2, and 3. Where we can meet the period which divide the number after it. Which one is harmonic? Which one no? Which one is harmonic? Which one is not? The harmonic is the list of number or the list of period where we can divide each number after it. Anyone can tell me? Okay. Look here. Look to this example. 5. If we divide 5, if we divide 10, is 10 divided by 5? Yes. The half of 10 is 5. Is 6 divide the number after it? Yes. Is 4 divide the number after it? No. So this is not harmonic. This is harmonic and this is harmonic. In this case, if we find the harmonic situations, in this case, the utilization will be equal, the utilization bound, sorry, will be equal to 1. As I explained just now, the utilization bound equal 1, that's in EDF case. That's in EDF case. But there is a specific case for rate monotonic when we face any harmonic type of periods, which each period can divide the number after it, like I show you in this example, here and here. Okay. In this case, if we meet any harmonic period, the utilization bound will be equal to 1. Same EDF case. Okay. Yeah, okay. Let's take one more example. Let's take one more example how to draw the rate monotonic schedule. Okay, we have this example. Can you see the slide, students? Can you see the slide?
Yes, sir.
Okay, so we have this example here, how to show you how to find the how to schedule the EDF and how to schedule to the rate monotonic schedule. EDF, I will explain it next time. Let's focus now on RMS, rate monotonic. Okay, let's take this example. Task 1. Task 1, 5 and 2. And task 2, 7 and 4. Okay, 7 and 4. So, first of all, we need to draw the timing diagram from 0 until what is the hyper period will be here?
7, sir.
The hyper period is 7. Are you sure? The hyper period, anyone? Try to find the least common multiple. I already teach you how to find the least common multiple.
35, sir.
35, exactly. So the timing diagram will be from 0 until 35. Okay. 5, 10. Okay. So which one has higher priority here?
Task 1.
Task 1 has higher priority. So task 1 has a priority than task
2.
2. What the next step here? After that, we find already the higher priority. What the next step? What we need to do now? Anyone?
Draw the flame line.
Yeah, show the frame of each task. Okay, we start with the task 1. Task 1. The period is 5, each 5 unit. Okay, for task 2, each 7. The period is 7, okay? So each 7, then 14, 21, 28, and 35. Okay? So from 0, how many tasks ready to execute?
2 tasks, sir.
2 tasks. Task 1 and task
2.
okay? But which one we need to execute?
Task 1 first.
Task 1 first, because
Higher priority.
has higher priority. So we execute task 1. How many unit we need to execute of task 1?
2.
2 unit. So we execute 2 unit of task 1. Then
Task 2.
then task 2. How many unit? We
Can execute only 3.
only 3. From
Yes.
2
until 5.
until 5. We stop at 5. Why?
Because task 1 priority, high priority.
Yes. Because task 1 has higher priority, task 1 will preempt task 2. We again execute task 1, since has higher priority. How many unit?
2.
2. Okay. Then
Task 2,
task 2. How many unit?
1.
1. Only 1, yeah?
Yes.
Then
Then continue with task 2.
continue with task
2.
2. How many unit?
1, 2. 2.
2 unit. Then
Start with task 1.
start with task 1.
2
How many
unit.
unit?
2 units.
2 unit. Okay, then
And then there's two units remaining in task 2.
2 unit remaining of task 2.
2, yes.
So we execute 2
Okay,
unit here.
2. Yes.
Everyone agree with him? Everyone agree with him?
Yes, sir.
Yeah, agree with him. Okay. I have a question now. Following the given question, task 1 need to execute 2 unit, each 5 unit, correct? Each 5 unit, we need to execute 2 unit. Task 2, each 7 unit, we need to execute only 4, correct?
Yes.
Okay. So take a look here. This is the first period of task 2, and this is the second period of task 2, correct?
Okay, yes, sir.
How many unit we execute in the second period?
Seven.
Huh? How many unit of task 2? How many unit of task 2 we execute? 5, correct. We execute 5.
Five.
This is 1,
5.
this is
2.
2, and this is 2.
Yes, 5.
So the total is 5. But the given question, we need to execute only 4 each period, correct?
Yes.
So how we execute 5 here? Anyone? It's correct. All our drawing until now, it's correct. But why? Why correct? Even though we need to execute 4 unit for each period, here we execute 5. Why?
Because end of the second period, end of the first frame of the task 2, we need to consider the priority first, where we need to execute the task 1 before we execute the task 2. So although the task 2 we haven't finished yet, but we need to base on the priority. So we need to execute the task 1, then we can start the previous.
Yeah, that's mean in simple word, that's mean we have missed deadline. We have missed deadline of task 2, correct? For the first period, just now you said, for the first period, we need to execute 4 unit, correct me? But we execute only
Yeah.
3, not
Three.
2.
3, yeah, 3.
3 unit,
Yes.
okay? One missing, one unit is missing.
Yes.
Where is
Yeah.
that? Where is that missing unit? Where is it? Can you specify
After
At the
it?
7.
7 to 8,
Yes.
correct?
Yep.
7 to 8.
Yes.
That's the way how to find the missed deadline, because in the question it will be asking you please schedule these tasks following rate monotonic and EDF and specify the missed deadline. Specify the missed deadline. You have to specify it like that. For example, will be our missed deadline. Okay, as showing here.
Okay.
as showing here. Okay, this is will be our missed deadline from 7 to 8. Okay, so let's continue. Let's continue. What we can here at 14, what we can execute at 14?
Nothing, sir.
Nothing.
Yes.
Are you agree with him? Nothing to execute at 14? Other students, try to participate, please. Seriously, it will help you to understand this type of algorithm, because we will meet too many type of algorithm in the future. Not only there's rate monotonic and EDF. This is, like simple introduction of this subject, real-time system. So try to participate, everyone. So nothing here. It will be idle. Yeah.
Yes, sir.
Here will be idle. Everyone agree? We can continue with task 1.
Yes.
May, are you agree with him?
Yes, I think so.
But I
Because
see
based
you are
on
not, you say, because what?
based on the given period and execution time, supposed to be yes, or the ideal time from 14 to 15.
Should be idle. Other student agree? Can we continue?
Agree, sir.
Agree. Okay. So let me remind you, the first period of task 2, this is the first period of task 2. This is the second period of task 2, and this is the third period of task 2. So you still agree with idle? You still agree with your answer?
No, sir.
No, sir.
No. So there's a new period of task 2. There's
Yes.
a new period of task 2. That means we still continue to execute task 2. Please pay attention on each, why we need to define each period, because this is very important. You will do some mistakes like just now. So here at 14, new period of task 2 means we execute task 2. New period, okay? Just forget about the previous one. New period, since there is no missed deadline, or then we specify the missed deadline. Okay, here new period of task 2, we execute task 2. How many unit?
1.
1 unit. Because task 1 start a new period of task 1, and task 1 has higher priority, task
Yes.
1 will preempt task 2. How many unit?
2.
2 unit. Then,
Then we'll execute the remaining task 2.
which is how many unit?
3.
3.
Yes.
1, 2, 3. Then
Then continue with task 1.
task 1, how many unit? 2 unit.
1.
1 because
There's task 2.
task 2. Are you sure?
Okay, but the priority is higher, right, for task 1?
Yeah. So task 2 cannot preempt task 1.
Yeah, so still it can contain two units.
Yeah. So we continue that 2 unit because task
Yes.
2 cannot preempt task 1, since
Yes.
task 2 has lower priority. Then
Continue with task 2.
start, actually, not continue, because there's a new period. There's a new period of task 2, you see?
Oh, okay.
So not continue. This we already done. The previous period done. So start with task 2. How many unit? Should be 4, but how many unit we can execute?
3.
3. Because task 1 will preempt task 2. Okay. Then
Task 1.
task 1, how many unit?
2 units.
Then
There is a task task 2 remaining 1 unit.
1 unit, correct.
So continue with the task 2, 2 units.
Start with task 2 because this is done. This period done. Okay, so there's a new period of task 2.
Yes.
How many unit we can execute here?
2.
2 unit.
So
Task 2.
then task 1, 2 units.
Then task 1, 2 unit.
And then task 2, 2 units.
The rest of task 2,
2 units.
2 unit, because in the new period, this is new period. Okay. In this period, we execute only 2 units, so the left will be 2 units.
Yes.
Then at 50,
Ideal.
this will be idle.
Yes, sir.
Yes, excellent. Okay, student, do you understand now? It's too simple, yeah? And here how to find the missed deadline. Okay, this will be idle. And here our missed deadline. Understand?
Yes, sir.
Any questions? Student, do you have any questions?
So far, no, sir.
So
So far, no. Okay. So